Hello. So hopefully by now you got the textbook. Um, so today I'm going to talk about chapter 0. Maybe have a chance to go into, I'll give a little bit of overview of this course. And then this screen is showing the Discord. So hopefully you can register into Discord. You can ask questions here. We can discuss. All right. Now I want to share. I want to go to the textbook. Hold on 1 second. Okay, so this is the textbook. And right, that's the textbook title. It's included in the syllabus. So make sure you get the same version, the required version of it. So chapter 0 basically is a review. It's a review for the previous knowledge we need for this course. So I'm going to quickly go over this. It's all about functions, all about functions. But we're not going to cover all functions. We're going to cover a couple functions I recorded the last video. Basically, polynomial functions, rational functions, exponential functions, and logarithmic functions. Those functions are our focus for this course. So chapter 0 talk about functions and their graphs. Functions we can express in mathematical expression, and also we can graph it. And some important functions, as I mentioned, there's 4 kinds we're going to focus on. Zeros of functions. What does it mean, zeros of functions? It means the x-intercepts. So when the function value, which is a y value, equals 0, so what x value causes the function value to be 0? So that's zeros of functions. Exponents and the power functions, all right. Let me see, how do I... Oh, okay, it's better to go from here. So linear function can be written in the standard form like this: ax plus by equals c. And we can solve for y to write this standard version into intercept slope form, into y equals mx plus b. So m measures the slope, the rate of change of x and y, plus b. B is y value of the y-intercept. X equals a is a vertical line. You see this line in 2 dimensions, all these points on the blue line, the x value equals a. So that's why x equals a in 2 dimensions is a straight line, is a vertical line. So this is a linear, so the typical, so this is a slope being positive. So we have this line. If slope is negative, we'll go through like second quadrant and fourth quadrant. So those are 4 quadrants, right? First quadrant, second quadrant, third quadrant, fourth quadrant. And then y equals b is a horizontal line. Right? So x equals some number is a vertical line. Y equals a number is a horizontal line because it is independent of x value. So y always equals to b in this case. And then y equals b is a function. It's called a constant function. Constant function. But x equals to a value is not a function. It's just an equation. Right? We can graph a linear function. Well, to graph a linear function, we only need 2 points. We can give x a certain value. In this case, you see x equals 0. We solve for y equals -2, so we get a 1 point. We give x value to be 1, we'll get another point. X value equals 2, we get another point. So we need 2 points to graph, but we want to do the third point as a checkpoint. So these 3 points has to be on the same line. If not, that means we did some calculation wrong. So in life, we have applications. Right? We have applications for linear function. So this line, the slope is negative, right? X value increases, Y value decreases. So this is an example cost function, right? Cost function in this case given as a linear function. The cost depends on this variable X, right? So it depends on the number of copies sold. So this is a linear function. When we talk about intercepts, we have 2 kinds of intercepts. We have x-intercepts, we have y-intercepts. When x equals 0, that's called y-intercepts. So maybe let me write this. So imagine we have this graph, we have these coordinates. The points on y-axis, so this is y-axis, this is the x-axis. All those points get a name, y-intercept. Because y is y-intercept, x value is always 0. Right? Y could be any other number. And versus if the points fall on x-axis, those points called x-intercepts or zeros of the function. Zeros of the function or x-intercept because the y value is always 0. X can be any number. If we know x-intercept, y-intercept, we can graph the linear function. Piecewise defined function, which means one function acts differently in different domains, in piecewise domain. So what is this? This is saying when x value goes from -1 to 1, let's graph it. But maybe this is x value equals -1, this is 1. So in this domain, function acts as this, right? We can graph this, let's graph this. So if x equals 1, we have 5/2 minus 1/2, which is 4/2, which is 2. So x equals 1, y equals 2. Let's say this is 2. So we have this point. When x equals 0, because 0 is the easy one, right? X equals -half. So let's see, this is a -2, -1, then -half will be here. Yeah, when x equals 0, be -half. And then when x equals -1, well, -1, that becomes -5/2 minus 1/2, which is a -6/2, which is -3. So the graph in this, yeah, not so good, huh? In this domain, from -1 to 1 acts this way. Well, when x is greater than 1, we don't know if when x is less than -1, right? We don't know about that, but we know x is defined for x greater than 1. So when x is greater than 1, we have this. We could use 2, right? If x equals 2, what happens? Because 2 is greater than 1. Well, 2 times half, that's 1. 1 minus 2, that's -1. So when x equals to 2, y equals to -1. Let me graph in green color. So we got this point somewhere, this point, right? We could do x equals 3 when x equals 3. Oh, let's do 4, right? Because 3 is a difficult number. Let's do 4. So when x equals 4, half of 4 is 2. 2 minus 2 is 0. We get an x-intercept. So greater than 1, but not equal to 1. So what do? We make an open circle. So I'm going to erase this. So here, at x value is 2, y value is -2, we're going to make an open circle. Then we're going to connect those 2 points. This keeps going. So that's the graph of this piecewise function. Right? You see 2 pieces. In this case, we have 2 pieces because the domain is being separated into 2 intervals. 2 intervals, right? One interval is from -1 to 1. One interval is from -1 up to infinity. Okay, that's that. Let's clear all the joins. If I'm going too fast for you, you can always stop and wind back to watch. Okay, actually, that's the graph. That's the graph. You see this open circle? That's very important. Okay, the open circle. Because when we talk about limit, this becomes very important to us. Right? Last video, I talked about what's nice about the polynomial functions is one piece of a string, is one. But here we see 2 pieces of strings, right? We see from -1 to 1 is one piece, you know, from this point to infinity is another piece. So here we have 2 pieces of string. It's being cut off at the value equal x value equals to 1. Okay, the second polynomial function is called a quadratic function. So polynomial function, we have mentioned 3 of them already. Constant function, which is f of x equals to a value. Let's see 3. Linear function, maybe 2x minus 1. We have slope-intercept form. Now quadratic function, which is degree polynomial degree 2. Polynomial degree 0, polynomial degree 1, polynomial degree 2. That's quadratic function. Quadratic function in the graph is either upward parabola or downward parabola. So this is the standard form. So this is a standard form for quadratic function. You see function f of x, right, is a function in terms of x equals to the ax squared plus bx plus c. B and C may be 0, but A will never be 0. Because if A is 0, it won't be quadratic function anymore. Because we need x squared to appear. So that means A cannot be 0. So it's a parabola, right? If A is greater than 1, we have an upward parabola. If A is less than 1, this A, the number before x squared, is a downward parabola. And the vortex, right? This is a formula for the vortex. The x value equals to negative b over 2a. Remember, where does a and b come from? The standard form is ax squared plus bx plus c. That's how we draw ABC. Let's see, give an example. If I have f of x equal to 2x squared minus x plus 1, then A will be 2, B will be -1, and C will be 1. Okay, so the vortex, what is a vortex? When we go upward, the lowest point is called a vortex. When it's downward, the highest point is called a vortex. So the x value is negative b over 2a. The y value, the function value, is you just plug in this x value into the function. Well, polynomial goes up to n degree, right? X raised by n, then an cannot be 0. This example of degree 3, then g is an example of degree 4. So the second type of function is rational functions. I already talked about. Right? H of x, you see, is a polynomial function divided by another polynomial function. Right? This is a rational function. The numerator is a polynomial function, and the denominator is a polynomial function. Power function. Power function is we only have the leading term, x raised by n. Absolute value function, or absolute value of x equals x if x is positive. If x is negative, we negate the negative. Right? Negative become positive. The graph is this, is a V shape. It's a V shape. Because once we absolute the negative value of x, it becomes positive. Well, functions can be represented in algebraic expressions, right? P of x equals R of x minus C of x. So profit equals revenue minus cost, and each one can be a function. And in this case, let's see, we have cost function as a linear function, revenue function as a linear function. And we subtract those two, we can get another function. So some algebras, when we multiply a number with, let me use this. When we multiply something with a fraction, we multiply to its numerator, because something by itself just is divided by 1. Right? If I have x, what does x mean? X is x divided by 1. So when we multiply with something, let's see, multiply with 1/3. I just multiply numerator with numerator, 1 times x, x, 3 times 1, 3. If the numerator and the denominator has a common factor of c, can be simplified, because what is c divided by c? That's 1. Right? So a times b multiplied by 1, of course, is still a divided by b. And when we do division of two fractions, we change the division into multiplication. We'll flip over the numerator and denominator. You see, it's c divided by d. Now it's d divided by c. Then we multiply numerator with numerator, denominator with denominator. But when we add two fractions, we need the common denominators. Let's say 1/2 plus 1/3. We cannot just go ahead to add those, right? It's different from 1/2 multiply 1/3. When we multiply numerator with numerator, denominator with denominator. But when we add, we need to make a common denominators. So we need to multiply by 1, which is 3/3 for this case. We need to multiply by 1, which is 2/2. Because 3 divided by 3 is still 1, right? But by doing so, we change this to be 3/6 plus 2/6. Now, the denominator is the same, we can add. Right? 3 plus 2, 5. So functions, when we calculate or evaluate, they are real numbers. So anything with real numbers, we can do with functions. We can add to functions, can subtract functions, we can divide two functions, provided the denominator will never be 0. We can multiply two functions. This shows some examples. So how do we add? We add by like terms, right? 2x, 2x are like terms. That becomes a 4x. 4 and minus 6, Those are numbers, they are like terms. That becomes -2. Okay, we can divide two functions. Once they have a common factor, in this case, we see 2 divided by 2, that becomes 1. So we simplify. We can multiply two factors. Right? This is called a FOIL. We multiply 2x with 2x, 4 with 6, then 2x with -6, and 4 with 2x. Then we get a quadratic function. Then we simplify by the like terms. So this gives some examples of adding. So how do we add those two rational? We need a common denominator. Right? We multiply the first one by x minus 1 divided by x minus 1. You see we multiply by 1. We multiply by 1. Because anything multiplied by 1, the value won't change. Because we need a common denominator. So then the first one becomes 2 times x minus 1. The denominator becomes x times x minus 1. Because when we have two terms, we want to put it inside the parentheses. Once we have a common denominator, we can perform the operation with the numerators. Then in the end, we simplify. We can also multiply two functions. Right? We multiply numerator with numerator, denominator with denominator. If each one is a fraction, we can also divide or multiply. But when we divide, we change the division to multiplication. We flip over the second one, right, which is the inverse of the second one. Then we multiply. Okay, composition of functions. So this is a bigger concept. Composition of functions. We have two functions, f and g. We can compose them. We can compose f with g or g with f. Okay, what does this mean? This case means f takes g as input. Right? So let's see the function f of x. So in this case, it's simple. X is the input. Right? You can imagine a machine. This is a machine. Right? So you input x, the machine is f. You input x inside this machine, then this machine outputs f of x. Now with this one, you have layers. Right? You input f, you output g. Now you put another machine. Now your input is g. Then your f. So you output f of g. Right? So basically what you can think is you just take the g of x as input. And in this case, g takes f of x as input. Okay, let's see what happened. Let's see the example. Let's take, so f takes g as input. So let's write one more step. Let's write here. So f takes g as input. Right? G is x minus 5. So let's write down x minus 5. So now the x minus 5 is my input. Now what do? Now I look at this function. What does f function do? Function f says square the input, the first one. Square the input. So what is my input? My input is x minus 5. Square it. Then plus 3 multiplied by the input. Then plus 1. Right? Because the input is not x, but is g of x. So square the input plus 3 multiplied by the input plus 1. So the input G is x minus 5 to change, right? Then do some calculation. So in the end, simplify to get a quadratic function. Well, G of x is the same thing. Let's write one more step. Okay. So G takes f as input. What's f? F is x squared plus 3x plus 1. What does G do? G takes input, subtract 5. G takes input. What's the input? Input is x squared plus 3x plus 1. That's the input. Then minus 5. Right? That's it. Then simplify it. Oops, what did I do? Okay, that's the composition functions. Make sure you understand the concept. Okay, evaluate a function. So here comes the first formula. We're going to use this in limit. Well, actually, before I go any further, before I forget, because I forgot to do it in the first video. So in this course, we're going to cover 3 concepts, 3 new concepts. Okay, so starting from chapter 1. So the first one is called the limit. The second one is called differentiation. What is the differentiation? Differentiation. Consider rate of change. What does the limit consider? Remember, we see the piecewise function, right? We see in this domain, one piece like this. In the other domain, we have this open circle. It acts like this. Remember the piecewise function? So in this case, we have to consider the limit. Remember that happens at x value equals 1. So we have to consider the limit. So how the function behaves on the left-hand side of 1, on the right-hand side of 1. So that's why we need the idea, we need the concept of limit. So the limit concerns of these situations. Differentiation concerns the rate of change, right? Let's see the simplest one, in the linear function. So m is a slope, but with differentiation in calculus, we would call the derivative of the function. So we consider the rate of change of function with 2 variables. So which means how one variable change affects the other variable change. So what is the rate of that? So 3 is integral. Integral is anti-differentiation. So it's the opposite. Anti-differentiation. So basically it's the opposite of this differentiation. Let's give an example saying, okay, I have this weird shape, right? Let's see, like a potato shape. I want to calculate its area. You know, the algebra we learn in high school won't help us to do that, right? We only know how to find the area for triangle, for square, for rectangle, so on and so forth, for the straight ones, or maybe for a circle, right? For a circle, actually, we can approximate the area. So for weird shapes, so what do? We can consider the bottom to be a function, the top to be a function, or maybe we cut somewhere, right? Then we want to integrate, which means we want to anti-differentiate. Okay, that's the purpose, one of the purpose of doing integration. So that's the 3 concepts we're going to cover for this course. So this one, we call difference quotient when we talk about the limit. Difference quotient. So what does this do? So x plus h, think about one point on x-axis. X plus h means the point in the neighborhood, very close to this point. Very close to this point. H could be a positive value, that will be this point. H can be a negative value, which will be this point. H is considered very, very small value. So basically, the f of x plus h minus f of x, right? The difference of the y value. What is h? H comes from x plus h minus x, right? X minus x becomes 0 plus h. So that's how this h come from. If we remember, given 2 points, right? Let's say x1, y1, and x2, y2. And we can write down, we can find the slope of those 2 points, right? I have 1 point here, I have 1 point here in space. So from this point A to this point B, what is the rate? How fast I can move from A to B? So what do? We do y2 minus y1, the difference in height. Once we put it in the coordinates, right? This is x. So let's put this one. This is x1, y1, x2, y2, right? And this point will be x2, y1. So we will find the difference in y. So people call rise over run. Right? How much we have to rise, how much we have to run. So that's a slope formula, right? Rise over run. So the rise is a difference in y value. Run is a difference in x value. So that's how we find the speed of change from this point to this point. So that's we call slope. We call slope. And in this case, we see this is just exactly the slope formula. The 1 point is x value is x plus h. Y value is f of x plus h. This is 1 point. Another point is x and f of x, right? So this is our y2. This is x2, y2. This is x1, y1. So we have y2 minus y1 divided by x2 minus x1. X2 minus x1, in this case, just h. So it's still the slope formula. It's a slope formula. It's still considered the rate of change. The rate of change from x, f of x, to the point of x plus h, f of x plus h. Right, still the slope formula. And of course, because h happens in the denominator, h cannot be 0. Because if h is 0, the 2 points are the same point. But we will, when we talk about limit, right, what we're going to do is we're going to let h approach to 0. So that's the miracle of limits. Right? H cannot be 0. However, we want to consider what happens when h gets closer and closer to 0. All right, so this is called a difference quotient. So now let's see how do we calculate. So let's say here we have a function. Where the function is x raised by 3. Well, that's a lot of calculation, by the way. I'm going to do a simple version. All right. So this is a lot of calculation. Okay, instead of do the completed version, I'm going to do a simple version. Let's do f of x equals to x squared. So how do we calculate? So first, we need to f of x plus h. That would be x plus h squared. What is that? FOIL it. Square the first one, 2 times the first one times the second one, square the second one. Then we do f of x plus h minus f of x. That's x squared plus 2xh plus h squared minus, that's f of x plus h, minus f of x, well, f of x is x squared. Then we see these two terms cancel each other. So I'm left with 2xh plus h squared. Now we do the last step. We do f of x plus h minus f of x. We divide by h. So we take this one, 2xh plus h squared. We divide by h, right? We can factor h from the numerator. Right, 2xh, h squared. But once we factor out, remember h divided by h equals 1. So we're left with 2x plus h. That's it. That's the difference quotient of this one. But now let's see the cube. F of x equals x cubed. So after the tedious calculation, in the end, the difference quotient is this. It's a 3x squared plus 3xh plus h squared. All right, it's okay. This gives an example. Okay. So I'm going to leave the next 3 things for next video, all right? Hope this helps.